Okay, so I would basically be talking about the components of a research paper here today in this lecture. And first I would be talking about a uh, general content of a research paper. Then I would more specifically be talking about the problems that have been shared with you and how you can proceed with writing the research paper. Okay. So normally a research paper has got the following content. So the first thing that a research paper has is a title. So what should be the title of any research work that you are doing is quite important, and it is the first thing that anybody in the research community who is interested in knowing about the research that you are doing would know about from the title that you have given for that research work in the paper. So I will be coming to that, how to write the title of a research paper after a while, because normally the title of the work is given after the completion of the paper. Okay, kindly remember this, that we do not give the title of the work unless until we have completely written the complete paper. Okay, so this is the last thing that you have to do, is to give a catchy and suitable title to the work that you have done. Next is the abstract. These are basically the sections that are normally present in any research paper. The second one is your abstract. Again, the content of abstract is written at last. So three things are there in the content of a research paper. The first one is the title, then the second one is the abstract, and the third one, which is the conclusion. So these things are written after completing rest of the sections of the paper. So I would be coming to it after some time. So the third thing is the introduction. Okay. So the introduction of a research paper, basically it starts with talking about the problem that you are going to tackle in your work, or that you have tackled in your work. Okay. The second thing that should be there in the introduction section is the work that has already been done in the area, work already done by the fellow researchers. So normally this is also referred to as literature that is already available on the problem that you are going to tackle in your work. Okay. And the third thing that should be part of introduction, and normally the reviewers who do reviewing of your work before it is published in any journal or conference, they ask you to keep a brief summary of the contribution of the work. Contribution of your work, maybe in a highlighted form or in a paragraph, in which you will be talking about what are the works that you have undertaken and you are reporting it in paper. Okay, so this constitutes the introduction. So introduction has a problem that you would be addressing. Okay, then the work that have already been taken in that area to take up or to solve that particular problem which you are talking about here in the early part of the section of introduction. Okay, and normally this part is normally it is of 2 page or 3 page, depending on the length that is desirable by the journal in which you are publishing your work. And in some conferences, the total length of paper, as asked by the publisher, is very less, say 6 pages or 8 pages. Then you have to restrict this to 1 or 1.5 page. Okay. So normally introduction should be in 1 to 2 pages. And you should report. The important thing is that the work undertaken by the fellow researchers in recent years. That means within 3 or 4 years that has been taken, the work reported in the literature should be mentioned in the paper. Okay. Although you may mention some of the earlier works that have been taken by the researchers, maybe 10-20 years back also, so that could form the basis for all the work that have happened up till now. That is also possible, but it is always good to include the work of the people who have been doing it in, and the results that they have reported in last few years. And this actually should have 3 sections. So the highlight, you should be highlighting what are the highlighting things in the work done by other people. So the highlight should be to mention the significant contribution of the various researchers, and then you should also report the results here that have been reported by researchers, and the shortcomings, if you could able to identify, that is quite good. Okay, so these are normally mentioned in this part, literature reviewing. Okay, then the third part is actually the wait a minute. Okay, so the third part is it is called the problem formulation. The problem formulation, or the third section of the paper should be about the problem formulation. So in this, one should develop the mathematics behind the problem. Okay, develop the mathematics behind the problem. Okay, what it means? Basically, it means to convert the given problem in mathematical equation form. Okay, convert the given problem in solvable mathematical form. Okay, so this is your problem formulation, and normally in again it should be within 1 or at most 2 pages. Okay, 1 to 2 pages. Then the next part of the paper is about the methodology adopted to tackle the given problem. Okay, so the mathematical form of the problem you have already derived here in this section. Now, in the next section, which is about methodology adopted, is the way in which you intend to solve that mathematical form of the problem. Okay, so methodology adopted is basically the steps or the method that you employ to solve the mathematical form of the problem. Since I am restricting myself to the problems of engineering, and this will even work for science problems also. So normally any problem in engineering has to be reduced into some solvable mathematical form, and that needs to be solved by some method, okay, in this section, and that is reported in this section, the methodology adopted. Okay, and then this method, the method that is adopted, it should be backed by some well established theory or analysis or mathematics. Okay, so you have to basically utilize the existing mathematical concept or theoretical concept to solve the mathematical form of the problem. Okay, so, and it may happen that you can develop your own way of looking and solving the problem. Okay, so, but definitely that has a backing of some well established theory or analysis and mathematics. Fine. And then comes the next part, which is called the next section, which is the reporting of the result obtained. Reporting of the result, and normally results are obtained by way of some simulation models that have been developed to tackle the problem, or some in form of codes, okay, or in some form of some graphs or some charts, or if you are working on hardware, so you have got some hardware results when you have analyzed some problem and you have converted into mathematical form, and you try to then obtain it. Say if you are working on circuits, then you take the results in hardware setup. Okay, and then all these things then need to be analyzed. So analyzing the result is one of the important part of this section. So reporting the result should be followed by analyzing the result, and then similarly it should be followed by it should write about the result, the inference, write about, or you should put in the inferences that you obtained from the result. Okay, And normally you should also mention here the various specifications and parameters, specifications and the parameters that you have taken for your taking the result. It is better to mention it in some tabulated form. Okay. Say for example, if you have taken hardware results, then what are the specifications of various components of the circuit? Like you have used inductor or capacitor or some voltage supply. Okay, so you need to, or some switches. So you need to mention the rating of those switches, manufacturer details of manufacturer, and all those things need to be mentioned in this section. Then comes comparison. So once you have taken the result, it is okay, it's fine, but you need to compare those results with what the people have already obtained earlier and which you found out in literature. Okay, so it is quite important that you include this section of comparison. And normally in any journal or any conference paper, reviewers do ask for including a section of comparison of the results with the existing work. Okay, and the comparison should definitely be based on some well-defined parameters. Okay, and then finally we have the last section, rather second last section, is your conclusion. So after comparison, you have got this conclusion section, and you have to very precisely you have to tell about your findings. The important findings. And very specifically, you also have to mention about the results. Okay, so it should be part of the conclusion. Okay, then finally, the last part of a paper, research paper, is the reference or references. So already the existing work that are there that needs to be highlighted, and you have to mention them, and these works need to be cited in the introduction part, or even if requirement is there, in the methodology part of the paper. Okay, so I left two parts earlier. The first part was your abstract, the second part was your abstract. So normally after doing all these things, you come to the abstract, and in abstract there should be an introduction, very brief introduction of the problem. The detailed introduction you have already given in the next section. A very brief introduction to the problem, and then it should have the approach, your approach in solving that problem. And it should also briefly mention the result, and not in form of numbers, or it should be in sentences form. Okay, and then finally come to the title of the work. So title should reflect some contribution, some significant contribution that you have made in the work. it should highlight, and title should not be say of one line or at most two lines at most, and it should be written in such a way that it highlights the main contribution of your work. And at times you may even mention some of the methods that you have adopted in tackling the problem. Okay, is it fine? So this is all about a general approach in writing a research paper in engineering, normally, more specifically engineering, and even it could include paper in sciences also. Now come to our problem. Okay, so let me go back and let me start from where we left. So let me take up the problem that I had given to you. Okay. So I had given you a few problems. We can categorize them into, say, one of the problem was about solar PV MPPT. Okay. And other was also of parameter extraction. Okay, actually, let me write it in a separate page. That would be better. Add one more page and let me write it here. So the first problem that I gave you was about MPPT tracking in solar PV, and the other part was your parameter extraction. So talking about it specifically, let me just quickly tell you what is this MPPT tracking problem. Actually, I would be sharing with you some of the research papers already in the area, and then you have to read it, and then you have to write important contribution of the various researchers for this specific problem. And let me tell you what exactly this MPPT tracking problem is. I had told you that in a solar PV system, we need to extract power from it. Okay. So, but the problem is that the IV characteristic of an IV characteristic of a PV cell is not linear. It is non-linear like this. And if you multiply I and V and try to plot P versus V curve, it looks somewhat like this. Okay. So there is only one unique point in the IV characteristic where the power is maximum. That means this is your solar panel and this is your, say, load. So if you are going to connect that load R to that panel, then definitely some amount of current will be drawn from this panel and some voltage will be there. And if you change this R, then this I and V is going to change. That means at different values of R, we will have operating point at different places in this IV characteristic. So correspond, then the power drawn from the panel is this. Okay. Let me take a different color. Let me take red. So the power drawn is this. Okay. And if the IV point is here corresponding to some value of R, then this is the power. So only one value of R, say R max, let me call it R max. So this value of R max is here, and that will correspond to this P max power. But the issue is that we are not allowed to change the load. Load is fixed. Load is normally fixed, isn't it? So how to tackle this problem? I had told you that what we need to do, we have to introduce one DC to DC converter in between the load and the panel. So this DC to DC converter, it could be, normally is a boost converter, say. Okay, so boost converter is something like this. So here is the panel, this is the panel, and normally a blocking diode is also there, so that reverse current do not flow here. And then normally we add a capacitor at the input side as well as the output side. Okay, so what happens, you have to control this switch. This is a switch, normally it is an IGBT or it is a MOSFET. Okay, so you have to control this. So by turning it on and off, actually you are changing the value of resistance seen by this PV panel. Okay, so you are not changing the resistance, you are only changing the duty ratio of this duty ratio D of this switch, and by doing so you can change the resistance or load seen by the panel, by this panel. Okay, so if I can keep this D at a value which corresponds to a resistance R max as seen by the PV panel, then I have achieved my objective. Okay, so how to do it? Then the question is how to do it. So normally there are conventional methods to do it, and conventional method, one of the conventional method is hill climbing method. Hill climbing method. And in hill climbing method, what we do, we try to find out the slope of the PV curve. This is your P, and this is on the x-axis is V. So if dP by dV is equal to 0, that means we are here. And if dP by dV is, say if it is greater than 0, then we are on the left side of this line. And if dP by dV is less than 0, then we are on the right side of this line, right side of the curve. Okay, and in both the cases, here and here, we won't be getting maximum power until we get this dP by dV equal to 0. Okay, so this is how this hill climbing method works. It tries to find out this dP by dV. Since we are working in digital system, so dP by dV is not obtained, rather delta P by delta V is obtained. Okay, the final power and initial power. We change the value of DT ratio and check this value, delta V by delta P by delta V. If that is coming closer to 0, and we set some tolerance value. So if delta P by delta V is less than that tolerance value, we stop changing the value of D. That means we have reached close to the value of the maximum power point. Okay, so that is the concept. So is it fine? So when you are writing research paper, in research paper, what you will be doing when you are writing Mppt paper? So the first part would definitely be the introduction part. You don't have to do, you don't change the section name, let it be introduction. And now you have to write about this problem that I mentioned. I mentioned the problem that maximum power is available at a single point, and we need to, so whatever I told you, you have to write it in this section. Okay. Then the next part, you have to mention the contribution of various researchers. Okay. So what are the various methods? One of the method I told you, hill climbing method is there. And one more thing I forgot to tell you is that there is, the problem is not that very simple. It is even complex when there are multiple panels that are connected in series and they receive different insolation. So this insolation is say 1000 watt per meter square. This is say 800 watt per meter square, and this is say 600 watt per meter square. So the problem becomes more complex, and say we have to actually add diodes in parallel to these panels to avoid a problem called hotspot. So these things you will get these information, detailed problem you will get in literature review. So once you study those papers, which I will share with you, you will be able to come across many problems that are there in solar PV system and tracking the maximum power point. And then you have to mention all those here and the contribution of the authors here. Okay. So in this case, there are multiple peaks. So dP by dV issue, dP by dV method of obtaining the maximum power fails here. Then we have to do something else. So that's where your work will come. You have to think over it, how we are going to find out that at which value of voltage we are getting the maximum power. Okay. Then the second section was your the problem formulation. So in problem formulation, you have to now write down the mathematical form of this problem. Problem is known. Now the mathematical form. Mathematical form, how will you write? You have to write down the equation I and V. So there is a relation between I and V. I is the PV current and V is the PV voltage. And then you have to find out power. That will be a separate function which will involve P and V and I. And then you have to minimize that. You have to maximize this equation. Maximize this function. Okay. Now, what would be the method that you will be adopting to maximize this PV equation or PV curve? That you will be mentioning in the third part, which is the methodology. The methodology. Okay. So normally in recent times, people have been using some meta-heuristic algorithms to tackle this problem. So individually, I would be talking about the groups, what method we should adopt, and I would even encourage you to think of your way to solve this problem, which we encounter in maximum power point tracking in solar PV system. So this is one of the problem that I had gave you. The second problem was pertaining to multi-level inverter. The second was your multi, whatever you call, multi-level inverter. Let me quickly talk about this also. You know what is an inverter? Inverter is basically a power electronic converter which converts a DC voltage into an AC voltage. Okay, and if I talk about the circuit of an inverter, it looks somewhat like this. So we have this battery VDC, and we have 4 switches. These are switches, IGBTs. Okay. So 1, 2, 3, and 4, and load is here. So what is the output when I connect 1 and 2? When I connect 1 and 2 are on, and 3 and 4 are off. 1 and 2 are on, then what is the output voltage? This is plus VDC will be at this point, minus VDC, or my negative terminal of this VDC would be here. Okay, so plus VDC would be appearing across the load. Similarly, when 3 and 4 are on, then what will happen? The negative voltage. minus VDC, because if this gets connected and this gets connected, okay, now you see that this terminal gets connected to this positive VDC, so voltage reverses. So this is the voltage that would be appearing across the load, and similarly you have to go on doing this. But the problem with this inverter output is that it is a square wave output. Okay, and square wave, if you try to see the harmonic profile of this waveform, so in harmonic profile is very bad. Okay, so apart from the fundamental, there are multiple harmonics that would be coming. The third, the fifth, the seventh. Although the even harmonics will be absent because it has got symmetry. This waveform has got symmetry, but the third, fifth, seventh harmonics would be present. Okay, and the total harmonic distortion is also very high. It is close to 48%. So the problem is most of your equipment or the load, they require pure AC supply to work. Pure AC supply. Pure AC sine wave supply. Okay. To work effectively. Say for example, the load is a motor, an induction motor. So what is the input to an induction motor? Say single phase induction motor is there. So we require AC wave, if sine wave as input. So if sine wave is not there and square wave you are giving to a single phase induction motor, then definitely there would be some issues. What will be those issues? The issues would be the losses will increase in the induction motor. It will produce noise. Okay, and then so these problems will start coming. So most of the load, AC load, they work well when a pure sine wave is given to them. But how to obtain a pure sine wave from this square wave inverter? It is not possible here right now with this configuration. Okay. So what researchers have done, they have suggested to go for, say, cascading these inverters. Okay. Let me take another page. So what they say, take this H bridge and cascade it with another H bridge. Okay, cascade it with another H bridge. Sorry, and this is your load here, and this is your input supply. This is so with two input supply, VDC1 and VDC2. Now you have the option to say one of the DC. This is producing this waveform, and this inverter second unit of CHB is producing, say, you can produce like this waveform. It is possible, okay, by controlling the switches. And if you add them, if you are cascading, that means you are adding them. So now the output would look somewhat like this. Okay. So something like this. Fine. So now this has got steps. There are steps, isn't it? And you can increase the steps by increasing the number of units. Okay. And even switching sequence can increase the number of steps here. So you could have multiple step output voltage waveform. Okay. And they actually closely resemble a sine wave. And the THD for them is very less compared to a 2-level inverter. Okay, it reduces, say, for a 9 level or 11 level, it becomes less than 10% without any filter. So filter requirement also reduces. One thing I forgot to tell, that filter is required when you are working with two-level inverter to eliminate those harmonics and make this waveform close to sinusoidal wave. But the size of the filter means passive filter I'm talking about, L and C are there. So the requirement would be, you will be requiring higher value of L and C to eliminate the harmonics. So thus it will become bulky. Okay, the inductor and capacitor is there, and rating, higher rating values of L and C definitely means more cost. So this is the problem. So we have to go for multi-level inverter. In multi-level inverter, so now the problem is either you develop your own topology, okay, which takes care of the fact that you have to use minimum number of DC supply and lesser number of switches. Okay, so if you are going to develop some new topology which could be using lesser number of DC supply and lesser switches, then that would be considered as a better topology, because it would be offering a closed sine wave output voltage waveform with better harmonic profile at much lower cost. That is one of the problem. And the second problem could be is about controlling this voltage waveform. Once you have generated it, but say if you are working with induction motor, so you know that induction motor, we have V by F control is there. Okay, you need to control V and you need to control F. So even V control is possible, so you have to change this voltage. So how to change this voltage? So you need to adopt some modulation schemes. Okay, so this is one of the area in which you can work. So when you are writing paper on this multi-level inverter, you will first start with, let me take one more page. So in multi-level inverter, again, you have to start with the introduction, and then I would be sharing with you some of the papers. You have to thoroughly read it. First, you have to mention the problem with the conventional inverter and come up with what are the possible solutions. Okay, then the solution suggested by literature. Then you have to mention your method, and before that even you have to form the problem formulation. So when in problem formulation, you have to reduce the problem in some mathematical form. Okay, so how you can do that? So we can write down the THD expression. It has got some mathematical form. Then work on how to reduce that THD. Okay, so this is how you can, or if you are working with topology, then you can come with the relation between the number of levels versus the switch requirement, and there are some other parameters also which determine the usefulness of an inverter, such as your peak inverse voltage. We also called it standing voltage in multi-level inverter. That needs to be less as possible. So this is how you write this section on problem formulation. Okay. Then what is the method you have adopted? So you'll discuss about the methods, like if we are working with modulation scheme, then there are low frequency modulation scheme, SHE. High frequency modulation scheme is also there. PWM scheme is level shifted and phase shifted. And we have options to do some research in all these areas. Okay. Then finally, one thing I was interested in telling you, that you have to, when I will share with you the papers, research papers, then how you will proceed. So first of all, try to read the paper and keep with you copy with you and note down the important contribution. Note important contribution. Okay. Fine. And then when we will try to formulate the problem, then at that time you will require my help and I would be helping you at that time. Okay. But the important thing is that you have to write down the introduction part with the help of already existing literature. Okay. And you have to write it in your own words. Okay. And avoid plagiarism. I had told you, I think, in the previous lecture. Plagiarism. This is an unethical practice. Okay. Fine. So these are some of the important things that I was interested in sharing with you. Now you are free to ask the question.
सर आपने सर हाई गेन डीसी कन्वर्टर के बारे में नहीं बताया.
Okay, now the third problem was with the high gain DC to DC converter. High gain DC to DC converter. So I had already told you the boost converter circuit is something like this. Okay. So this is the input side and this is the output side. Why we use DC to DC converter? We are interested in actually changing the DC, a constant DC level, to a variable DC level. Okay, because in many applications the load requires DC supply. Okay. Take the case of say battery charging. So a battery requires DC supply for charging. Fine. Say your mobile battery, it requires 5 volt supply. Take the case of laptop. It requires 23, 19, so 15 volts. So different specifications are there for the battery of laptop. Okay. But say you have a battery from where you are going to charge it, that battery is of 12 volt, normally available, the commercial battery. Okay. So how you are going to charge this mobile battery and laptop battery, which have a different specification, charging specification? Definitely you need to change this 12 volt into this 5 volt or 19 or 23 or 15 volt, isn't it? So for that we require a DC to DC converter. Okay. But you see, in normal DC to DC converter, let me take another page. In normal DC to DC converter, normally there are 3. One is your buck, the second is your boost, the third one is your buck boost. So what are the issues? Let me tell first of all. So in buck converter, the output voltage is normally D times V. VO is D into V input. In boost converter, it is V0 is V in by 1 minus D. And in buck boost, we have V0 equals to D times V in by 1 minus D. D is the duty ratio and it varies from 0 to 1. 0 is less than. Okay. So that means in buck converter, you can always obtain an voltage, output voltage, which is less than the input voltage. In boost converter, you can always obtain a voltage which is greater than the input voltage. While in case of buck boost converter, so from 0 to 0.5 you have buck operation, while from 0.5 to 1 you have boost operation. So buck and boost, both operations are possible. But now coming to the issues. What are the issues? Issue number one is the first issue is low gain. In case of boost as well as buck boost, the output voltage gain you could see here is 1 by 1 minus D. So if I try to plot it, say this is VO by V in. VO is the output voltage, V in is the input voltage. Have you studied DC to DC converter in power electronics course?
Yes, sir.
Okay. So from 0 to 1. So what would be the value of this gain if I try to find it and try to plot it here, V0 by V in? So it starts from this value 1 for boost converter. It starts from 1. And if you go by this ideal equation, it should go like this. At D equals to 1, VO should be infinity, isn't it? But can voltage be infinity? Definitely no. It is not infinity. So this is actually the average output voltage, and theoretically, although it looks like that VO will be very high, infinity at D equals 1, but it is not the case. What happens? After certain values, say 0.6 or 0.7, instead of increasing, the output voltage start decreasing and it reduces to 0 at D equals to 1. Okay. So the gain is not very high, normally 3 to 4 times, even that is even difficult. A gain of 3 to 4 times. So you have got say 12 volt supply available with you, and at most you can go up to 48 volts when you are using a boost converter. Okay. But say the requirement is you want to, for example, you want to connect this panel, you want to connect it to grid. Okay. ठीक है, definitely you directly नहीं होगा. First you have to convert into AC form and then, but the voltage of grid is quite high. So how to obtain, say from 12 volt I am interested in making into 40 volt DC. Then only I can convert it into AC, which is at par with the grid voltage. So definitely I am not going to obtain it with the help of this boost converter. I have to do something else. So I have to change the configuration of the boost converter. I have to incorporate some other elements like inductor and capacitor and make that circuit high gain. Okay, wherein I can obtain an output voltage which is a function of say D square or square and thing like that, which is called quadratic boost converter and something like that, which is called high gain DC to DC converter. Okay. So this is about the topology. You have to develop newer topology to have a configuration in which you can obtain a very high gain output from a given input voltage. So that is high gain boost converters. Okay. Then the other issue is also, अच्छा यहाँ पर मैंने buck boost का ये expression का, this is not sorry, this is minus of this much. Minus आ जाता है तो invert हो जाता है input voltage. The input voltage get converted. तो ये भी एक problem. So and there are other multiple issues with the conventional inverters. So we have multiple topologies that have been suggested by researchers, especially in recent decade, 1 decade, and they have come up with various topologies in DC-DC converter configuration in which very high gain output is possible at lower D. Achha, one more thing, you should obtain a very high value of output at lower D. Why? Because so higher D means the more time the switch is on. Higher D means D. D, what is D? This is D. Yeah, on, and this is off. So this entire duration is T. T on. Call it T on. And this is your T. Sorry, this is T and this is T on. And this time is T off. So D is basically T on by T. So higher value of D means T on is more. So this is here, here. Okay, that means high for longer time the switch is on. The switch is on for longer time. So if switch is on for longer time, what will happen? Losses will increase, isn't it? So if we could obtain a value of high gain at lower D, then our switches will have a lesser loss. So these are some of the issues that we will address when you will work on high gain DC to DC converter. Okay. I hope I have addressed your query also.